Hi, let's take a look at graphing inequalities. But first, let's remind ourselves what inequalities are. Well, one thing is that they use this kind of symbol here. In this case, it's less than or equal. So the left-hand side is less than or equal to the right-hand side. This means that the left-hand side is greater than the right-hand side here. So we'll be using those kinds of symbols here. But as a lead-in here first, we need to take another look at graphing just a plain old line. So y equals x over 2 plus 2. Now we have a line that's going through plus 2 on the y-axis and has a slope of 1/2. There's that line. But now let me throw a curve at you here. Let's change the equal sign to a greater than sign. What that means now is that we want all the points represented by the orange box there that are above the line y equals x over 2 plus 2. Now if I say greater than or equal, then I want all the points above that line and including the points that are on that line. So that's how we'll be doing these. So the first thing we need to do here is graph the line y equals x over 3 minus 3 on our axis here. So it goes through -3 and it has a slope of 1/3. So let's draw that line in. Now we want everything, all the points that are below but not including the line y equals x over 3 minus 3, represented by the orange again, or yellow. Okay, here we go. Now this one we have to work a little bit more on. Let's put it in the standard form of equation of a line. So we have to work this out. Let's go ahead and first add 2x to both sides, and then we divide through by a -5. Now, when you divide through by negative on equalities, you change the direction of the inequality sign. So we got greater than or equal. So now let's draw the line y equals -2/5 x minus 2. Now we want everything that's above that line, including the points that are on the line, represented by our yellow box here. So first you have to draw the equation of the line as like a base point and then go from there. So here we go. Put this in the standard form of a line. Let's subtract 2x from both sides, and then let's divide through by 3. We don't have to change the sign around this time because it's not negative. And so now we want to graph the line y equals -2x over 3 plus 2. It goes through 2 on the y-axis with a slope of -2/3. And we want all the points that are above that line. That's our solution set for this equation here. So it's a little bit trickier here than actually graphing a single line. So here's another one. Beware on this one here, we'll be dividing through by a negative, but first we take and we subtract 4x from both sides, and then we divide through by a -5, and again we need to switch the symbol around, in this case the less than or equal sign around, and so we get greater than or equal. So first graph the line y equals 4/5 x minus 3, goes through -3 on the y-axis, and slope of 4/5. Now we want everything that's all the points that are above that line, including the line. So I hope you're catching on to this. Now this case here, x greater than or equal to -2. Let's first draw the graph of x equals -2. So that is actually a straight up and down line going through -3 on the x-axis. Now when it says greater than or equal, then we want everything to the right of that line, including the line. We can do a similar thing here involving our next problem, y is greater than 3. This time we get a horizontal line that goes through 3 on the y-axis. So let's draw in the line y equals 3 first. Okay, it goes through 3 on the y-axis here. Now we want all the points that are above that line but not on that line. Now the last problem here is going to be a little bit tricky, so you better pay attention to this here. Okay, we are going to intersect two lines and see where their solution sets overlap. Okay, here's our first line here, line A, y greater than or equal to 2x. Graph the line y equals 2x to go through the origin there. Now we'll want all the points that are greater than that line and on that line. And then we graph line B, which would be graph y equals -1/5 x plus 2. We want everything that's above that line. So what we're going to do is get an area where both solution sets overlap here, and represented by that triangular area. So that's our solution set in the graphing of this problem here. Thank you.